Graph neural network for 3D multi-object tracking. Our work contributes a new 3D multi-object tracking method that can learn more discriminative object features with graph neural networks. Although there are different categories of 3D MOT methods, recent work tends to focus on this standard tracking by detection pipeline to approach 3D MOT. First, this pipeline takes the sensor data as inputs, where the sensor data is often data point clouds or RGB frames, or a combination of them. Second, we feed the sensor data into a 3D detection module to output detection results, often represented by 3D bounding boxes. Then, a data association module takes the bounding box results as inputs to obtain final object trajectories in the 3D space. In general, the data association consists of two submodules, feature extraction and bipartite matching. First, the feature extraction module obtains features for each current detection and path trajectory, which are then used to construct an affinity matrix. Then bipartite matching is performed by taking the affinity matrix as inputs and output the matching between the current detection and path trajectories, which are then used to create new trajectories in the current frame. Okay, we have talked about the standard 3D MOD pipeline. In this work, we address two limitations in the feature extraction module. First, feature representation used in prior work does not take into account context of other objects. Second, feature representation does not fully utilize data from multiple modalities. To deal with this limitation, our work has two contributions. First, we provide a novel feature interaction mechanism to encode context for each object feature via object interaction. Second, we introduce a 2D 3D joint feature extractor to learn multimodal features for data association. To illustrate our contributions, we draw one figure here that compares our work with prior work. In the top, we can see that prior work extracts feature representation of each object independently. This means that feature of each object is isolated with other objects without any context. Also, the feature is extracted either from the 2D input data or from the 3D input data. In contrast, our method uses a joint 2D and 3D feature extractor to learn multimodal features. After extracting features for each object independently, we perform a novel feature interaction so that the context information across objects can be encoded, which is crucial to learn discriminative features for data association. We have talked about the key ideas of our method. Now let's take a deeper look at how exactly we do. Our proposed feature learning process has three modules. First, we obtain the object motion and appearance feature from the 3D space. Then, in a similar way, we obtain the object motion and appearance feature from the 2D space. Finally, we update the object feature through object interaction using graph neural networks. Now let's talk about the results of our 3D MOT system. We have talked about the idea of multimodal feature learning, so is that really useful? First, we look at the performance by using a single feature here. We denote A for the appearance and M for the motion feature. We can see that if we use multiple features, the performance is generally improved. Especially in the last row, where we use all four features, we obtain a further improvement of the performance. The other question is that, is the feature interaction using graph neural networks useful? Again, we conduct the ablation study where we evaluate the performance of our method with different number of GNN layers. If we use 0 GNN layer, it means that we do not perform the object interaction at all. We can see that if we use 3 GNN layers, we observed a significant improvement, about 3 to 4 points on both matrices. Okay, qualitative results. We visualized 3D trajectory outputs as corner 3D bounding boxes. Each corner box represents a single object tracked by our system. We show that our system can produce stable 3D trajectories over time across different sequences. Thank you for watching.